The maximum weight that a rectangular beam can support varies jointly as its width and the square of its height, and inversely as its length. If a beam 1/4 foot wide, 1/3 foot high, and 10 feet long can support 30 tons, find how much a similar beam can support if the beam is 1/3 foot wide, 1/2 foot high, and 18 feet long. So remember here that it tells us that the maximum weight a beam can support varies jointly as width and square of height, and inversely as length. Those are going to be really important as we put this equation together so we can solve. Let's talk about our variables here. K is going to be our constant. M is going to be the maximum weight that a beam can hold. W is the width. H is the height. And L is the length. So the equations we're going to use for this problem are our joint and inverse variations. Remember that it said that the maximum weight a beam can support varies jointly as width and square of height, and inversely as length. So we're going to take our joint variation equation, which is y equals kxz, and because it varies jointly with width and square of height, we're going to plug in our width and our square of height in for our x and z. And it varies inversely as length, so we're going to use our inverse variation and plug in length as our x there, and we're going to combine the two, always having a constant. So this is what it's going to look like. We have the maximum weight varies jointly with the width and the square of the height, and inversely as the length, always with our constant there. In this particular problem, we are going to solve for k, which is the constant. Remember that the width was 1/4 foot, 1/4 feet wide. The height was 1/3 feet. The length is 10 feet, and the maximum weight that it can hold is 30 tons. So now we just have to plug those numbers into our formula. The maximum weight that it'll hold is 30. We keep our constant, that is what we'll solve for. Our width is 1/4. Our height is 1/3. Don't forget to square that. And then our length is 10. When we solve for k, we get 10,800. Now we're going to use that to solve for the second beam. So the second beam tells us that it's 1/3 foot wide, 1/2 foot high, and 18 feet long. We do have our constant now, so we are going to solve for the maximum weight that the second beam can hold. So this time we do m equals, our constant is 10,800. Our width is 1/3, and our height is 1/2. I'm going to square that. Our length is 18. When we solve for that, we get 50. So the maximum weight a beam 1/3 foot wide, 1/2 foot high, and 18 feet long can hold is 50 tons, and that is the answer.